All right, guys, here's going to be a quick tutorial on finding the molar mass of compounds or molecules. Okay, so in the previous video, we went over how to use molar mass of elements. Okay, now we're using the molar mass of compounds, and this works pretty similarly. The only thing is you got to add stuff up. So for our first one, H2O, okay, we're going to have to use the periodic table again, but the way I like to calculate the molar masses is by writing everything out first. So we have hydrogen, we have oxygen, okay? If we go to the periodic table, and again, we go to our periodic table, we find hydrogen is 1.008 grams. And then let's go over to oxygen, which happens to be 15.999 grams. And then I'm going to go back to our problem. Okay. That's what we do. We find out the molar masses first. Now we have to multiply the molar masses by how many we have. So if we look at hydrogen, okay, hydrogen has a subscript of 2. So we're going to multiply hydrogen by 2. Okay. Oxygen doesn't have a subscript. Okay. So we just have to multiply that by 1. And then all we have to do is add it up. So in the end, all we're doing is adding up all the molar masses of the elements that make up the compound. So if we plug that into our calculator, 1.008 times 2 plus 15.999, okay, that's going to give us a total of 18.015 grams H2O per mole. Okay. Actually, I'm going to rewrite that. Okay. I don't feel like we're recording the video for this. Grams per mole of H2O. Okay, that's probably a better way to write that. Okay. Now let's move on to the next one. Okay. So same thing. We're going to count out what we got. We got iron and we got oxygen. Okay. So I know that iron is 55.847 grams. Okay. I just know that because I've used it so much. Okay. We know that oxygen, we just looked it up, is 15.999 grams per mole. Okay. And now again, we have to multiply by how many we have. Iron has a subscript of 2 times 2. Oxygen has a subscript of 3 times 3. And then we just plug it into our calculators. Okay. So 55.847 times 2, okay, plus 15.999 times 3 is going to give us a total of 159.691 grams per mole Fe2O3. Okay, and that's, again, just how we're calculating the molar mass of a compound. Okay, so that's water, that's iron oxide, which happens to be rust. Okay, last example we'll go over. Okay, CaNO3 This is one where we can run into some difficulty. Okay, so we're gonna list out our elements. Okay, Ca, N, and O. Okay, I know 40.08 grams. I know 14.007 grams, and I know 15.999 grams. Okay, now we only have one calcium. The nitrogen has a subscript of 1, but because it's in parentheses, this 2 distributes. So nitrogen will be times 2. Same thing with oxygen. It's got a subscript of 3, but the 2 distributes. This will be times 6. We plug this into our calculators, and we get 15.999 times 6 plus 14.007 times 2 plus 40.08, and that's going to give us 164.08 0.88 grams per mole of CaNO3 2. All right, guys, that's just a quick tutorial of how to calculate molar mass of compound. Okay. As always, any questions, please let me know. Okay. Hope this helps. Have a great day.